All right, today we're going to talk about what happens when you got somebody moving away from you at, say, half the speed of light, and then they throw something, and then from their perspective, they've launched it at half the speed of light. Is that a way to sneak around relativity and end up getting massed objects to move at the speed of light? No, of course not. But here is a way we can solve for. Let's say you're hanging out and you happen to know the velocity. Let's say I send someone off in a spaceship going half the speed of light, and they launch a probe away from them, and from their perspective, it's moving away at half the speed of light. So this is the velocity I will see their probe moving away from me, and it won't just be the velocity of the spaceship plus the velocity of the probe. It'll be the spaceship plus the velocity of the probe over 1 plus velocity of the spaceship relative to me, velocity of the probe relative to the spaceship over c squared. So keep in mind, these guys, this requires the velocity of the, say, probe relative to the spaceship, not relative to me. So all the velocities are relative to me observing on the Earth, except for this guy, which is velocity of, say, probe relative to spaceship. So third relative to second. Everything else is relative to first frame of reference. So velocity of second relative to first frame of reference, velocity of third relative to second. Again, we have second relative to first and third relative to second. And all of that gives us the third relative to the first. This one is pretty much plug stuff in your formula. You also got to do, like, you remember back to kinematics, you got to pick a positive negative thing. So pick a direction to be negative and a direction to be positive. Aside from that, let's plug it in. Yeah. I usually try to make things, my answer is positive. So usually if I would end up with a final answer towards me, I would make towards me positive and away from me negative or something like that. So yeah, this is really largely a plug in the formula unit, which we don't have a ton of, but this is one of them, plus the make one direction positive, the other direction negative. So in this case, we've got an observer. Here's your first frame of reference, and he's got a student moving away from him at 0.8 times the speed of light. This guy is pretty fast. And then this student throws a ball at 0.75 times the speed of light from his perspective. And we want to know how fast the ball is moving relative to this guy. Now, anytime both things are moving in the same direction, because of this term, you basically use straight atom, but your term on the bottom will end up being positive if both these guys are in the same direction. And so the final answer will be smaller than you get by straight adding. Anyway, so for this question, you just plug it in. For the next question, you've got one going towards the observer, and then he throws the ball backwards relative to him, so away from the observer. I made towards the observer positive in this case, and away from the observer negative. You feel free to do the reverse. Anyway, if these two are not in the same direction, when you go in and do this top thing, your kind of big minus small, you're dividing by something that is less than 1. So your velocity would be bigger if than you would expect by just straight adding and subtracting if they're moving in opposite directions, and it will be smaller than you expect if they're moving in the same direction. So that's a bit of a check. All right. Again, this thing is largely just plugging in the numbers. It's pretty interesting. I kind of like this guy. You got a space vehicle traveling away from the Earth at a velocity of 0.8 times the speed of light, and they emit a light flash. Now, This is a trick question, though you don't have to treat it as such. Really, the way I would like you to solve for this is you'd be like, well, the second postulate of relativity states that the speed of light is the same for all observers. It is always 3 times 10 to the 8 meters per second in a vacuum. And so it doesn't matter what space vehicle launched this thing, everyone will perceive it moving at the speed of light, regardless of this business. But it's also interesting, hey, does the formula work? And if you put it in, notice the light flash is traveling at the speed of light. We put it all in. We end up with 1.8 C at the top and 1.8 on the bottom. And so we end up with C as well. So even if you didn't catch the trick question, if you just plugged it into the formula, that works too. And then this is about it for this guy. And the end of the snap portion of our relativity unit. Thanks for listening, and hopefully this helped.